Okay, now we're going to do a video on completing the square. I don't necessarily like the name for this, completing the square, but it has some interpretations that are accurate. I like to think of it as finding a perfect square within a quadratic. So that's a much longer title, harder to remember. But if you remember that, then you'll remember maybe what you're actually doing. So in this quadratic here, we want to change it to this form, where this is the perfect square. X plus h all squared is a perfect square, as we realize from factoring a perfect square. But then you have these other pieces, the number out in front and the k. So not every quadratic is a perfect square, but maybe we can find one within it and then rewrite the extra pieces. Okay, so that's exactly what we're doing. So when completing the square for a quadratic expression, one of the pieces will be a perfect square. That's the x plus h squared. Okay, so x plus h squared equals x squared plus 2hx plus h squared. Okay, so when you see something in this form, you can automatically factor it to x plus h squared. So half this term squared is this one. Sometimes we have to force it now, okay? So if a equals 1, so in this case, if a equals 1, let's look at this simple case. For something like x squared plus 6x plus 7, is this a perfect square? Well, what's half of 6? Half of 6 is 3. 3 squared is 9, so we would need a 9 there to make that a perfect square. So it's not a perfect square. Okay? So we find a perfect square within that and add or subtract the correction factor. Okay, so I call it a correction factor. So x squared plus 6x plus 7 is the same as x squared plus 6x, I don't change those first two terms, plus 9, so with just a plus 9 I couldn't put the equal sign there, but the plus 9 now makes it a perfect square. Half of 6 squared is 9. Now to make it equal, I need to put in this correction factor. Okay, so 9 minus 2 is 7, so that makes it equal. Okay, so once we've got this perfect square, I can now write it as a perfect square. Okay, and now you have x plus 3 squared minus 2. This is the result of completing the square. Okay, you need to have it in that form. Okay, another way is to add and subtract the same number to preserve equality. So I'm going to show you this way. This seems to be the way that most teachers will teach it, and it is more transferable to harder ones. Okay, so x squared plus 6x plus 7 equals x squared plus 6x, I don't change those first two terms in this case, plus 9. That plus 9 makes it a perfect square. Half of 6 squared is 9. If I then subtract 9, it's like I've done nothing. If I add 9 and subtract 9, I've done nothing, as long as I also keep the 7. Okay? So x squared plus 6x plus 7 is there, but then I put it in, it's called the do nothing rule, plus 9 minus 9. Okay? That does nothing to the whole thing except for change its looks. Now we can factor this part is x plus 3 squared, that's the perfect square, and then negative 9 plus 7 is negative 2. You get the same answer we got up here. Okay? If a not equal to 1, a is not equal to 1, then factor a out of the first two terms. So we're looking at ones where you might have a 2 or a 3 or something in front of the x squared now. Okay, if it's not a common factor. Okay, so what I want to do now is if a does not equal 1, then factor a to the first two terms, so not the constant term, okay, and complete the square for the part that is in the brackets. Then simplify the parts that are left. Okay, so I'm going to show you one like this. Okay. So, say you've got 2x squared minus 12x plus 7. This is not a perfect square, and you can't factor 2 out as a common factor. Okay? So what we do is we take 2 out of the first 2 terms. Not the third one, because you can, but it's just going to make things harder, and you end up with the same answer. So factor 2 out of the first 2 terms. Then complete the square on this part. Okay? So, to x squared minus 6x, in order to make it a perfect square, I need half of that squared, which is 9. So I need to do plus 9. There I have a perfect square. Now I need to subtract 9 to keep it equal. Okay? And the plus 7 stays out here. So we created a perfect square. Then you've got x minus 3 squared is this part. You still have the minus 9 and the plus 7. Okay? Now you have to multiply that 2 in. 2 into each part, so you're going to distribute it in. So 2 times the x minus 3 squared is here, and then 2 times the 9 minus. Okay? You still keep simplifying, get negative 18 for the 2 times 9. 2 times negative 9. And then put those together and you get minus 11. And now you've completed the square for something that has not 1 in front of the x squared. Okay? So that is that one. Now, in general for completing the square, I'm going to just show this to you. So basically, if you had to complete the square for something that looks like ax squared plus bx plus c, and you didn't have numbers, okay? This is going to become useful later on when we're looking at solving quadratic equations. Okay, if you didn't have numbers in, how would you go about doing this? This is the whole process. So I'm going to show this to you, though you should work through it first, and then see if you can get it to be the same. Okay? So there is completing the square in general. And that's all we have for the theory part. Now we're going to look at some examples. Okay, so the example here, we're going to look at x squared minus or plus 6x minus 4. Okay. We factor that, or to get the perfect square, so half of 6 is 3. I'm going to add 3 squared, I'm going to subtract 3 squared to keep it equal. That's the do nothing part. This is the perfect square. And the minus 4 is still there. Okay? And then we've got x plus 3 squared minus 9, because this is a perfect square, minus 9 minus 4. Minus 9 minus 4 gives us minus 13, and we're done that one. Okay? So another way of doing this is the original way that I showed you. X squared plus 6x plus 9 is the perfect square that relates to that. Okay? So I would need a plus 9 there, not a minus 4. And the correction factor here is going to be negative 13. You can just jump right to that. 9 minus 13 is negative 4. Okay, so there's the other way. And you get the right answer. Okay, x squared minus 3x plus 2. Half of 3, negative 3, is a fraction. Okay, so this is where it gets a little complicated. So x minus 3x stays the same. Then we've got to take half of this and square it. Well, when you square a negative, it's positive. So I'm just going to leave it as 3 over 2 squared. But then I have to minus 3 over 2 squared, plus 2. Okay, so plus 2 stays there. Now, this part here becomes the perfect square, x minus 3 halves, all squared. 3 over 2 squared is going to be 9 over 4. And then converting 2 to something over 4 is 8 over 4. Now we have a common denominator. We add those. Okay? Negative 9 over 4 plus 8 over 4 is negative 1 over 4. And you've completed the square. Okay? Here's another one. 3x squared minus 24x plus 7. So factor the 3 out of the first 2. It doesn't factor out of all of them, so you can only factor out of the first 2. Okay? Leaves it still kind of nice. So now you need to complete the square for this part. Half of negative 8 is 4, negative 4. 4 squared is 16. So you're going to add and subtract 4 squared to make the perfect square and keep it equal. Plus 7 stays there. Now you write the perfect square. This is a perfect square, x minus 4 squared. Okay, because a minus is there. That's 16. And now you need to bring the 3 in. 3 times that, 3 times that. Okay, so 3 times x minus 4 squared, and 3 times negative 16 is negative 48. Add those two together, and you've got the final answer. Okay, and here is one final one, which I'm going to show you. And it's a complicated one with fractions again. I'll just show you the solution. You can work it through. Okay, so maybe try it first and then see if you got the right answer. Okay, so there's the answer to that one. And that's all for completing the square.